Okay, hello everyone. Let's start this show. This is a demo for the Lambda Buffers project uh, for the second milestone, which is the end-to-end proof of concept. And we got in far, so let's see where we're at. What you see on the left-hand side of the screen is a Lambda Buffer schema definition that contains some types that I came up with, some domain that we try to explain by using the schema. It's called citizen. On the right hand side, we have a shell that's equipped with all the tools that the Lambda buffers as a toolkit provides. So there's like three tools. First of them is the Lambda buffer frontend that actually takes in the schema files, parses the textual representation, and then orchestrates the work with what we call the compiler and the codegen modules. And the Lambda buffers frontend is a very simple command line tool that anybody will be able to use. The second one that's also made available in the same environment is the actual compiler. This is that piece of the tooling that took most of our time because it's quite challenging to verify that the schemas are correct and what it means for schemas to be correct. And the LBG is what actually we truly care about, is going from a schema to generating code in at least two different target languages. For the sake of this milestone, we decided to use Haskell and then PureScript. So as you can see, there's a gen Haskell um, command, and there's a gen gen PureScript command, right? And they have some standardized interface. So these are the three little tools that essentially capture what Lambda Buffers a project is. And we will use those tools to process the citizen schema and generate some Haskell files with some implementations and see how we can work with the types that have been generated and with the code that has been generated. And we'll do the same thing with PureScript, but we'll do that in a separate video. This is only just gonna focus on the schema itself. So on the left hand side, we have a schema. This is a Lambda buffer schema. The files, so let's go into the API. It's the only file that we have in the API folder. It's called citizen. And you might see this in many different languages. This is a syntax that's highly inspired by Haskell and PureScript and functional languages in general. So what we have is some kind of, we declare this is a module called citizen, and then we have some imports. The Prelude and the Plutus and the two Plutus modules are part of the LBF base, which is a standard Lambda buffers library that contains all the common type that are going to be supported and used across plenty of different backends and target languages. So these are the imports, and now we have some comment, some definition of a record type. Uh, Derive is a statement which is essentially what Lambda buffers brought about as novelty, where we we state that citizen gets an EQ implementation derived, which means that citizens can be compared for equality. And this is standardized across all the different backends that Lambda buffers will support. We do the same thing with Plutus data, which essentially gives us the ability to store the citizen records in the Cardano network as datums, which was the whole motivating, inciting point of this project, what we got funding for, right? And so here we define a product type, which is just bytes. So we say name. Oh yes, let's just talk about what citizen is. A citizen is a record type that has three fields. The first one is The first one is first name, and the first name is of type name. The second field is called last name, and it's of type name as well. And the third one is called ID, and it's of type national ID. And we're gonna drill down into what these types are. So name is just a product type of Pluto's bytes, because we need to store these things on the Cardano network. So that means we need to use types that are native to the Cardano script environment. And for that, we just do this derive statements for each type, so everybody gets the ability to be compared for equality and to have the necessary encoding implementations for Pluto's data derived automatically derived for them. A national ID is a sum type, or sometimes called an enum type. And it essentially states that a national ID can be, and this is a very skewed example, of course, because I'm doing this for the milestone demo. A national ID can be either a Croatian passport that consists of a Croatian identification number and a picture, and either a Croatian passport or a Croatian ID card or a Swiss visa. And I see that I did a mistake here, so I'm just gonna fix that here, right? And so the first Croatian passport consists of an identification number and a picture. The ID card consists of just the identification number, and the Swiss visa just holds the information on the visa type, right? So the Croatian identification number is just an integer. The picture is just bytes, and the Swiss visa type is another sum type or enumerated type, and it can be either L, B, or C. And that's the whole schema file. On the right hand side, we prepared, you can also see it here, we prepared a make file that helps us invoke all these tools and get the generated code. So we can either just call make, or we can pick it apart and say, okay, let's first call the compiler. What does the compiler do? This is a debug flag, so we get the some intermediary representation dumped on the disk for a later inspection if something goes wrong. So this command essentially states that we are asking the Lambda Buffers frontend to compile our source schema. And we say, please compile source schema in debug mode with this compiler. And the compiler is the LBC tool that we provided to this environment. This is an internal detail, but since everything we did is exposed via an API, you can hot swap compiler and Cogent implementations, and the front end will not care. It's all the communication between them is sort of standardized by this API. -w, we're just setting a work a directory that the front end will use to store certain files that it uses to communicate with the compiler and the cogen. -is the location, a directory that contains our Lambda Buffer standard library, and the -e API, I'm sorry, -e, I, yeah, in Croatian, it's hard to spell English when you're Balkan. An API is where the directory where our citizen schema is, and then we are finally saying which module we want to compile, and that's essentially it. Oh, let's see what happened. So we are missing a type class rule. Perfect. Missing little error in module citizen, constraint Pluto's data. Plutus data for, uh-huh. So why does this work? Ah, no, it didn't work. Okay. Hmm. Oh, that's right. Oh, that's right. Um, let's see. Aha, yes. That's right. We didn't actually define an integer type for Plutus, but we can do that here. Okay, let's try and do that here. Okay, of course, something went wrong. So what happened was that the compiler actually told us that the integer from Prelude doesn't have a Plutus data instance declared for it, which is great because I did forget to declare it. Once I did, the compiler now, uh, you can on the left-hand side see what we needed to do. So this is the base Plutus module. We import the integer, and then what we say is just instance Plutus data on integers. So if we go back and now we reloaded the environment, and now we're back into the original environment here and in our citizen file, and when we say compile, it says everything works. Way great. And then let's see what the command for generating code is. This is specific for Haskell, and this is how it looks like. And then we can see what the auto-generated directory contains. And what we essentially care about is the citizen file and all the types and implementations that are generated from the schema. I will stop this video now and talk about Haskell part and the PureScript part in separate videos.